While hybrid and plug-in hybrids share many similarities with conventional vehicles, there are some notable differences. Both are very similar to conventional cars and trucks because they have most of the familiar components found in traditional vehicles, but with the addition of a medium or a high-voltage electrical system.
Electric vehicles are similar to hybrids, but without the traditional internal combustion engine. Since electric vehicles share the same principles and components of the electrical system in a hybrid, once you learn how a hybrid or plug-in hybrid works, that information can easily be applied to an electric vehicle. Here's a breakdown of the different components that can be found in hybrid and electric vehicles. Keep in mind that these components can be found in passenger vehicles and trucks and buses, although their location and function may vary. Internal combustion engines are found in hybrids and in electric vehicles with extended range capability. They can either propel the vehicle directly or produce electricity to run the electric motor. The hazards they present are the same as you would find in a conventional vehicle. Hybrid and electric vehicles use a 12-volt DC lead-acid battery, similar to what you would find in a conventional vehicle. 24-volt systems may also be found in medium and heavy-duty trucks and buses. This increase in voltage is accomplished by wiring two 12-volt batteries together in series. Some trucks may run a dual low-voltage system, incorporating both 12 and 24 volts into their ancillary systems. Similar to conventional vehicles, the low-voltage system supplies power to the ancillary systems, such as lighting and instrumentation. The location of these low-voltage batteries can vary, but disconnecting them is a critical step in shutting down the vehicle, as they play a key role in controlling the flow of electricity in the high-voltage system. Although most hybrids and all electric vehicles use a high-voltage battery, some hybrids may use a medium-voltage system. In either case, the battery is generally constructed in a similar manner and with similar materials. There are a few isolated applications where the medium-voltage system is powered by several low-voltage lead-acid batteries wired in series. For safety purposes, medium-voltage batteries should be considered just as potentially dangerous as high-voltage. For the purpose of this discussion, we will focus on the high-voltage battery. High-voltage batteries found in hybrid and electric vehicles are made up of a number of low-voltage cells wired in series to increase the overall voltage output. A typical battery pack in a passenger vehicle currently ranges in voltage from 100 volts to 400 volts DC, but can be as high as 600 volts and will likely be even higher in the future. High-voltage batteries in larger trucks and buses can reach 800 volts or more. The two primary types of high-voltage batteries found in electric and hybrid vehicles are nickel metal hydride and lithium ion. Nickel metal hydride has been the predominant battery used in hybrid systems, although it has begun to shift towards lithium ion, which is most commonly used in electric vehicles. These batteries are considered dry cell batteries, as the individual cells do not contain a liquid electrolyte like we see in a liquid-filled lead-acid battery. Each cell has only a small amount of electrolyte in a gel form and would only leak a minimum amount even if crushed. Even so, the electrolyte should be considered potentially corrosive, toxic, and/or flammable. If damaged, the high-voltage battery may give off harmful or flammable vapors. Use full PPE and SCBA and avoid direct contact with the battery, as it may also present a shock hazard. You should also know that some battery models are liquid-cooled. In the event of a battery breach, they may leak a fair amount of coolant, which is not to be confused with electrolyte. As always, there is a possibility of new technologies and new materials being used in battery construction in the future, so it is best to stay up to date on new developments. While locations of the batteries vary, there are some general guidelines that are helpful in finding the battery location. In passenger vehicles, the battery is almost always found in the rear of the vehicle, usually in the trunk area in sedans or under the second-row seating in many of the SUVs for hybrids. The battery in an electric vehicle is larger. It can typically be found under the passenger compartment, often in the floor itself. In trucks and buses, the location of the high-voltage batteries varies depending on the application. For example, on a transit bus, they can commonly be found on the roof. These battery configurations can weigh more than 700 pounds. In trucks and school buses, the batteries are commonly found along or within the frame rails. These are typically located behind the cab, although some may be found under the cab. Similar to electric passenger vehicles, electric trucks and buses will have larger batteries than their hybrid counterparts. In commercial applications, high-voltage batteries can power more than just the electric motors that propel the vehicle. They also may be used to run secondary systems traditionally powered off of a PTO, like a man lift or drilling attachment. It's important to note that multiple battery modules can be wired together to form a single, larger battery. As a result, responders should recognize that there will frequently be multiple high-voltage battery locations on these vehicles, not necessarily in the same location. While this is common in trucks and buses, it is likely to be incorporated into passenger vehicles in the future as well. The high-voltage system is controlled by the low-voltage system through relays located in the high-voltage battery. When the low-voltage current flows to the relay, it closes, and high-voltage current flows from the battery. When the low-voltage current is removed, the relay opens, and the high-voltage circuit is interrupted. Typically, high-voltage batteries use some type of service disconnect. Operating these service disconnects will disable the high-voltage circuits. Keep in mind, however, that batteries still retain their charge even if the rest of the circuit is isolated. Manufacturers vary in their recommendations on whether responders can operate these disconnects without specialized personal protective equipment. Consult the manufacturer's ERG or NFPA's Emergency Field Guide for these recommendations.